Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about Section 3.3, Solving Systems of Linear Inequalities. Our objectives are to solve systems of linear equalities. Our topics include linear inequalities and systems of linear inequalities. Now here we see a system of linear inequalities. That is, that it's two linear inequalities together with this brace in front. Now, you've graphed a single linear inequality already. We did that in the previous chapter. So graphing y is less than or equal to negative 2x plus 4 shouldn't be new. I draw the solid line y equals negative 2x plus 4, and then I shade below. You should be able to also graph y is greater than x minus 3. It's a dotted line, and we shade above the line x minus 3. So this is what it would look like when we shade them both on the same graph. Now, the solutions for this system of linear inequalities are all of the points in the region that get double shaded. So we see the region that gets shaded in the pink color. That's the numbers that are greater than x minus 3. We see this region that's shaded in the blue. Those are the ones that are less than negative 2x plus 4. So that region that gets shaded by both are all the solutions to our system of linear inequalities. If I choose the point 0, 0, I'm going to get a true statement with both of these inequalities. If I choose a point like 4, 2, it's going to satisfy the bottom inequality, but it's not going to satisfy the top inequality. If I choose a number like 4, negative 1, where it's not shaded at all, it's not going to work in either inequality. So really, graphing a system of linear inequalities isn't any different than graphing a single linear inequality. It's just that we have to do it multiple times. Now, if I wanted to graph this one, again, I graph the line y equals 3 halves x plus 2, and I shade above it. But what about this bottom one? This looks very different. Well, x equals 3 is a vertical line. So I would draw a dotted vertical line, x equals 3, and then I would shade to the left because that's where numbers are less than 3. So this is what my graph looks like. Again, all of the points in the double shaded region are solutions to this system of linear inequalities. Now, you're going to have problems where they ask you to graph a system of linear inequalities where there's quite a few of them. And then they want us to classify the figure created by the solution region. Basically, what you want to do is draw all 4 of these lines and shade in between. Now, if you shade in between, what you see on your paper is a parallelogram. You want to try to use as descriptive of a term as possible. I wouldn't just call this a quadrilateral because those blue lines and red lines, those are parallel. The green and purple lines, those are parallel. So this is actually a parallelogram, a special type of quadrilateral. Now, how do I know that the two lines are parallel? Well, the way that we know lines are parallel is we look at their slope. And we see that we have two horizontal lines, a slope of 0, and the two obtuse lines both have a slope of 3, so they are parallel. What about this system of inequalities? The top two are vertical lines. One of them we shade to the right of negative 2, one of them we shade to the left of 3. That bottom one is a horizontal line. When we graph it, we get this shape, and that's technically a trapezoid. The reason it's a trapezoid is because one set of opposite lines is parallel. Okay, basically that's it. A nice short chapter. I hope you find it easy. It's time to get to work. I'll see you in class, and I'll see you online.